In this video, we are going to see how the low pass filter and high pass filter response will look like from the CST simulation. So for that, I'm going to consider a square patch and dual of square patch for the CST simulation. Let's see how it. So I have used the periodic structure, condition, and unit cell simulation, phase reflection diagram. I'm going to use the time domain and then frequency from 1 to 10, finish. So I'm going to create the substrate and the square patch. Sorry. Going to take the FR4 substrate and D maybe I can give it as 10 mm, then H as 1.6 mm. Now I'm going to create a patch. L is the dimension of the patch as it is created over the substrate. It is from H to H plus 0.35 and I have given the PC. So L, maybe I can give it as 8. So I have created the structure. Now we have to give the boundary condition. As it is symmetric, we can give the electric and magnetic to whichever the position it is. And we have to give the open add space on Z min and Z max. And I'm going to create the ports Z positive, and for de-embedding I am for de-embedding I'm taking this value and putting it here. Sorry, I have removed the minus, so it will be de-embedded, and then other port also I'm creating, so it's in negative direction. So I'm taking this value and I'm going to give the de-embedding distance so that the port will be de-embedded on top of the patch. So here when you check the port, you can see it's de-embedded, and maybe start the simulation. So the simulation is complete. Now I'm going to check the S parameters. So S11, so here you can see that the value of S11 is less than -10 at the lower frequency. So at this frequency, it's getting passed. And when you check the S21, you can see that it is along 0 dB. This is the response of a low pass filter. So you can see that at lower frequency it will pass, and at higher frequency it will not pass. So the value, if the value of S11 is less, it means that it is passing that frequency, that is there is no reflection. So this is the response of the low pass filter. Now we are going to see how the response of high pass filter will look like. High pass filter is the dual of the low pass filter. Here you can see that if you take the dual of these patches, we will be getting a high pass filter. So let's see how we can do that in CST. So I'm going to create a patch with dimension same as the periodicity, so that I can subtract this patch, already created patch, from there, and we can have that dual. So this is the dimension. Okay, so now it is getting created. So we are going to subtract our patch from this solid. So we have the dual of the structure now, and we can do the, as I haven't changed the frequency, the port assignment is okay. The embedding is okay. So now I'm going to just do the simulation. Okay, so now the simulation is complete. Let's see what is the S11 and S21 response. Here we can see that S11 is almost 0 dB and it is getting below minus 10 dB at higher frequencies. So we can also see that the transmission is less than minus 10 dB at lower frequencies. This means that it is going to be like a high pass filter. Here we can see that at lower frequencies it is not getting anything passed, so everything is getting reflected back. So this is the response of the high pass filter. If you increase the frequency of simulation, you can see where it becomes less than minus 10 dB. So if you compare the low pass and high pass filter, you can see how it is. So this is for high pass filter, and oh, sorry, S11 high pass and S21, sorry, S21. So these are for S11 and S11 for high pass and low pass filter. That is for the low pass filter, S11 will be less than minus 10, and for high pass filter, S11 will be very high values. Similarly, for the S21, we can also see how the variation is happening. So this is how we are getting the low pass and high pass response from the patch and its dual structure. That is in effect for a low pass filter. This is the response. S11 will be very less and S21 will be very high value. And for the high pass filter, it will be the reverse. S11 will be very high value, that it is not transmitting anything at lower frequency. So I hope you get some idea about how it will be like for the low pass and high pass filters.